Welcome to Engineering Studio with Dr. Mohammad Tahir. In this video, we are going to discuss about the concept of grass area and net area. We will see how we can calculate the grass area as well as the net area at any section. So grass area, simply, in case of grass area, what we do, if it is a rectangular or a circular section, we can calculate the grass area at any point. So grass area will be at a location where there is no hole inside the member. So in case of rectangular, it will be simple b time h or b time d, and in case of circular, it will be pi d square by 4. But if we have some other structural shapes like W section, angle section, so for that either we can calculate the area by using the dimensions of flange and web, or otherwise, in case of standard structural members or standard structural shapes, we can have the table or the properties of this section in LRFD manual. So from there we can find the area of that section. So next is net area. When a tension member is connected using bolts, cross section reduces because of the hole present, and this is referred to as the net area. So the area at this section where there are holes inside the member, so area at this section will be termed as net area. So it will be equal to grass area minus area of holes. So here this is equal to grass area minus area of holes. So now we need to consider what will be the area of hole. So first, let's understand the concept, how much will be the diameter of this hole. For example, if we have the bolt diameter dB, then we need to punch the hole a little larger than that of diameter of bolt. So the diameter of bolt will be a little larger than that of bolt, and when we punch the hole in that plate, so the area surrounding this hole may be disturbed, may be damaged. So the effective area or the effective diameter of the hole, which we need to subtract from the grass area to get the net area, or the area which is resisting the applied load, so that diameter is termed as effective diameter. So mean area, diameter of bolt, diameter of hole, and surrounding this diameter there will be some diameter which is damaged. So we need to consider this diameter, and this diameter is termed as effective diameter of hole. Okay, to calculate the net area, we will subtract the area corresponding to this effective dia of hole from the grass area. Okay, so AN is equal to AG minus AH. AH is the area of hole. So area of hole is equal to N times diameter of bolt plus 3. So here, the diameter of bolt plus 3 mean diameter of bolt plus the diameter of hole. So that will be 1.5 millimeter or 2 millimeter larger than that of diameter of bolt. So this will become diameter of hole. But there is also some diameter which is damaged, so we consider it equal to 1.5 millimeter, mean 0.75 millimeter on one side and 0.75 millimeter on the other side. So it will be equal to 1.5 millimeter. So this much area or this much diameter dB plus 3, this will be equal to effective diameter. So N time effective diameter times thickness, it will give us the area of hole. So similarly, if we know the area of hole which is given for the standard bolts in AISC code, the standard diameter of hole is given corresponding to the bolt diameter. So in that case, if we use the diameter of hole instead of diameter of bolt, so the equation will become area of hole is equal to N time, N is the number of bolts in that line or at that section, diameter of hole plus 1.5, which is allowance for the damage. So this will become effective diameter times thickness, so it will give us effective area of hole. So here we can write it AE, effective area of hole. Here again effective area of hole. So AG minus effective area of hole, it will give us the net area. So N is the number of bolts along the failure plane or at the section that is under consideration. dB is the diameter of bolt, dH is the hole diameter, and T is the thickness. So area at this portion will be net area. Okay, here our table is given in AISC code, table J3.3. So here corresponding to the diameter of bolt, the standard diameter of hole is given. For example, for M16, the diameter of hole is 18 millimeter. It means it is 2 millimeter larger than that of bolt diameter. Okay, let's solve one example how we can calculate the net area at any section. So here it is stated that determine the net area of 10 by 200 millimeter plate joined with two 6 by 200 millimeter plates as shown in figure. The plates are connected to each other with two lines of 20 millimeter rivets. So here actually it is specified that find the net area of 10 millimeter plate, but if it is not specified, then we need to decide that which plate will govern or which area will govern to find out the net area, or for which plate we will find the net area that will be considered to calculate the capacity. So if we calculate the area of these plates at this critical section, here we have two plates, one plate this one and the second plate is this, and these are joined with the help of bolts in two rows. So at that section we see we have one plate of 10 millimeter dia and its width is 200 millimeters. So this dimension is 200. So here the gross area will be, the gross area of this single plate will be equal to 2000 millimeter square. And on the other side we have two plates each having 6 millimeter thickness and 200 millimeter width. So the area of these two plates which are acting collectively, their area will be equal to 2400 millimeter square. So we need to consider lesser of these two areas that will govern the capacity of the section. So here this 2000 millimeter is a smaller value, so this one area will be considered. Okay. The failure plane is vertical having two holes in its section, so N is 2. So now we need to consider, we need to calculate the AN net area. So to calculate the net area, we can say AN is equal to AG minus area of hole. And for area of hole or effective area of hole, we have N times diameter of hole, or we say diameter of bolt, plus 3 N times thickness. So N is the number of bolts which are along that critical section or at that section. So here if we see our critical section is over here and there are two bolts. If we take critical section at any location, two bolts will come in that path. So N is equal to 2. Diameter of bolt or rivet is given, which is 20 millimeter, and 3 is 1.5 plus 1.5. 1.5 for diameter of hole, allowance for the diameter of hole, and 1.5 millimeter for the allowance for damage. And T is the thickness of plate, and in case of this plate, because here 2000 millimeter area governs, so we need to consider this 10 millimeter thickness. If this area or the area of these two plates govern, then we need to consider the combined thickness of these two plates. So here we will consider 10 millimeter. So here it is 2000 millimeter is the gross area, N is 2 bolts, D is 23 plus T is 10. So from here we can find the net area. Okay, next is net area for staggered hole. Sometime we punch the holes which are in line in both the directions. They are in line in this direction as well as in line in this direction. So if this is the case, then we can consider or we can calculate the area just by using this equation as we have seen in the previous slide. But if we punch the hole like this, that if one hole is over here in one line, in the second line the hole will be not in this line but away from this line. So in this case, this horizontal distance from this vertical line will be termed as stagger of the hole. So in the two adjacent line, if the bolt of the second line are displaced from this vertical line or transverse line, then this displacement or this distance from this vertical line up to the center of the next hole will be equal to stagger, which is written as S. And the center to center spacing of the bolts in this direction, if this is the line of action of force, so this will be the pitch of the bolts. And the distance between these two lines of the bolts will be equal to gauge. So this is gauge, this is stagger, and this is pitch. So over here, if we see in this picture, so here it is pitch, this is gauge, distance between the two lines of the bolts transverse to this line of action of load. So this is gauge, and the distance, horizontal distance between the center of this hole and this hole, means two holes of the adjacent rows. So this is stagger S. So if this is the case, we have placed the holes not in line but staggered holes. So in that case, we need to add this much allowance for this stagger. So the remaining formula to calculate the net area will remain same, but we need to add this S square over 4G to account for this stagger, because if we consider this path, so this path will be longer than this vertical path. So in case of vertical path, we will consider this gross area minus the diameter of or the area of this hole. And here one thing need to understand, when we say that it is the area of hole, so it doesn't mean that we consider this periphery and the area of this periphery. Instead of this, we cut this hole at the center, and then we consider, if we draw its elevation after cutting, so we need to consider this much area. So the diameter of hole times its thickness. So instead of this curved path, we consider this straight path. So diameter of hole times thickness will be this much area. Okay, to account for the stagger, we need to add this much S square over 4G. But why we need to add this? Because when the path is changed like this, so the path will elongate. The path will be larger than this one. How much will be the difference between these two paths? That will be equal to S square over 4G. So this path will be larger, so we need to add this much S square over 4G. So if we see over here, so this one length as well as this one length and this third length. So this third length hypotenuse will be larger than this perpendicular and this base. So if we consider this path AB, so we need to consider this perpendicular, but if we consider this path AB and C or AC path, in that case we need to consider hypotenuse. So the difference of the length of perpendicular and hypotenuse will be equal to S square over 4G. So we need to add this factor for all the stagger in the critical path. So now we start reading from here. For a group of staggered holes along the tension direction, one must determine line that produces smallest net area. So we will consider this net area or this critical path, or this critical path. So we need to investigate all the possibilities, and we will consider the smallest area out of those critical path. Okay, path of failure on net section AB or AC. So here we can have two different paths, this AB or AC. So in this picture, P is pitch, S is stagger, and G is gauge distance. So for path AB, the net area will be equal to gross width minus diameter of hole. So if we subtract the diameter of this hole from this gross width and then we multiply it with the thickness, so it will give us the net area. It is actually equal to gross area minus area of hole. So T multiplied with the grass width, it will give grass area, and diameter of hole multiplied by the T, it will give us area of hole. Similarly, in the second equation for path AC, AN is equal to grass width minus area of hole plus S square over 4G, summation of S square over 4G. So here we have only single stagger, so we will consider only one time S square over 4G. S is the stagger and G is the gauge distance, and then multiply it with the T. Or if I write it like this, so it will become AG if I multiply it with T minus diameter of hole times thickness and plus, and we need to add this factor because here the length of path has increased. So S square over 4G into T we need to add. So if we compare these three, so the hypotenuse and perpendicular, and if I rotate it in this direction, so this will be a little bit longer. So this much length which is larger than this hypotenuse will be considered in this factor S square over 4G. So our net area for this path will become AG minus diameter of hole times T. So here we have two holes, so it will be multiplied by 2Rn plus S square over 4G. I hope you understand. So next we will solve one example, then it will be more clear. So here is the example to determine the net area of plate shown in figure, where the location of 20 millimeter diameter fastener is also indicated. So here we have 3 rows of bolts. So first row 1 and second bolt will be over here, and then the second row here, and the next bolt will be somewhat over here, and then the third row this one. So if we see for hole A and B we have stagger of 54, and B and D again we have a stagger of 54. For B and C we have a stagger of 48. We need to consider the horizontal distance between the two adjacent lines for the stagger value. Okay, so we need to investigate how many different paths are possible in this case. So the first critical path will be from A to D, and the second may be A, B and D, and the third might be A, B and C. So these 3 paths are possible. So first of all, the net area for path AD. So for path AD we have these 2 holes. So grass area, so we know the total width which is 305 for this plate, and its thickness is how much? 6 millimeter. So 6 multiplied by 305, it will give us the grass area times. So we need to check how many holes will come in this path. So A and D is 2 holes, so N will be 2 plus diameter of bolt plus 3 allows for the hole diameter as well as for the damage times thickness. So it will give us this area. So N times D plus 3 T. So here we don't have any stagger, so we need not to add S square plus 4G. Okay, next for path ABD, path A, B and D. So here again the net grass area will remain same. We will calculate simply by multiplying it with width and thickness. So 6 multiplied by 305. Then we need to subtract the area of these 3 holes. So 3 times diameter of bolt plus 3 times 6. So we have subtracted the area of these 3 holes. Next we need to consider the stagger, or we need to add the factor to consider this stagger. So we need to add S square over 4G for these 2 staggers. So for first case, in case of AB, so we have stagger value 54. So 54 square times 4 and G. So the gauge length between these A and B is 65. So 54 square over 4 times 65. And then for B and D, again the stagger is 54. So 54 square divided by 4 times, and the gauge length in case of B and D is 100. So 4 times 100. So we need to consider this and then multiply it with the thickness. So we need to add this much factor to account for these 2 staggers. So here we get the area 1527 millimeter square. Okay, next is the path A, B and C. For path ABC, Again, the grass area will be 6 times 305. And we need to subtract the area of these 3 holes. So we have 3 holes. Each hole have 20 millimeter dia of bolt, and then add 3 for the allowance times the thickness. So this will be the area of hole. Then we need to add the factor s square over 4g for these 2 staggers. So for the first case, the stagger is 54 divided by 65 is the gauge, plus for B to C we have stagger 48, so 48 square divided by gauge length is again 100, so multiplied by 6 the thickness of the plate. So in this way we can calculate the net area for path ABC. Now we need to check which one will be the critical path. So if we apply the load, so this failure will be along which path. So for all these 3 paths, the path which have the least area, that will be the governing area, or that will be the critical section. So here we have 1554, 1527 and 1518. So this one will be the critical area that will control, or the failure will occur along this path like this. Okay, so the previous that we have studied the net area, that was for simple straight plates. But if we have structural shapes like angle section or T section, channel section, for example channel section, so in that case we need to calculate the gauge length. And if in case of structural shapes the holes are not staggered, the holes, there may be 2 or 3 cases. The first case is the holes are present only in one leg. Then the procedure to calculate the net area will remain same as previous. And the second case is the holes are present in the both legs, but they are not staggered, they are in line. So in that case again the procedure will be similar to the previous one. But if the holes are present on both the legs but they are staggered, the holes of this one and this one are staggered, so in that case we need to consider the gauge length between this hole and this hole. So this gauge length will be considered along the center line of the member. So let's see what it says. When holes are staggered on 2 legs, so condition is holes are staggered and on 2 legs of an angle, the gauge length for use in s square over 4g expression is obtained by using length between centers of the hole measured along the center line of the angle. So we will measure the length from center of these 2 holes, and it will be measured along the center line of the angle. So if we measure the length from here to here, if we are given that the length from the center of hole up to this, which is gauge length, so if this is known GA, similarly this distance from this center or center of this hole up to this edge or this corner is gauge length, which is GB. So the distance from here up to here will be GB minus this much, half of the width of or thickness of this leg. So GB minus T by 2 will be the distance from here up to here, from the center of this hole up to this center line. Similarly, in this direction, distance from center line of the hole up to this center line, this will be equal to GA minus T by 2, this one. So the total length will become GA minus T by 2 plus GB minus T by 2. So the distance or the length of this center line from the center of this hole up to the center of next hole. So if we add these 2 values, so it will give us GA plus GB, mean gauge length for this hole and gauge length for this hole, minus thickness of the leg. So thickness of this leg and this leg. In case of angle section, we have the same thickness for both the legs, so we will subtract T out of this value, GA plus GB. Okay, so to calculate the net area, what we do, we actually translate this or rotate this section to make a straight plate. So we cut it over here and then rotate, so it will become member like this. So this one leg and this one leg will be rotated over here, and the distance between this bolt and up to the center here, this will be equal to GA plus GB minus T. So distance from this center or center of this hole, which is rotated after rotating in this direction, so distance here up to this center will be GA plus GB minus T. So this will be more clear when we will solve one example. So in AISC manual, some standard value for the gauge length are given. For example, for angle section, if we have only one bolt in the leg, in that case it will be denoted by G, and for different length of the legs or the leg dimensions, we have different values for G. For example, if the length of leg is 102 millimeter, then the gauge length for this bolt will be 64. And if we have more than one bolt, so then the first distance from this corner or from this edge up to the center of this first bolt will be G1, first gauge length, and then the distance between the next two bolt, between the center of the next two bolt will be G2. So G1 will be if the, for example, length of leg is 152 millimeter, if this length is 152 millimeter, then the first hole will be at a distance 64 millimeter, and the next hole, this hole will be at a distance 76 millimeter from the center of the first hole. So these are the standard gauge lengths which are given in the AISC manual. Similarly, for channel section, the gauge length for flange as well as for web is given. Okay, let's solve one example to learn how we can calculate the net area in case of structural shapes like angle section and channel section if the holes are staggered in the two legs. So it is stated that determine the net area AN for the given angle, for the angle given in figure this, if 18 millimeter diameter fastener are used. So the diameter of fastener or the bolt is 18 millimeter, and we have an angle section. On one leg we have one bolt, and on the other two legs we have two bolts, and it is angle section with 152 by 102 by 12.7. So this 102 leg is this one. So here we have only one bolt at a gauge length of 64, and in this longer leg 152 millimeter we have two bolts at a gauge distance 57 and 64. So if we see its elevation, this is the cross section and this is the elevation view. So this leg will be in elevation, this one. So here we have two lines of bolts, one line here and one line here, and these two lines are staggered, and the stagger of these bolts is 76, 76 and 76, the distance between these two bolts in horizontal direction. And this leg will be shown like this in the elevation, and this bolt is in line with the upper one. So this bolt as well as this bolt are in line. So the upper bolt and this bolt on the lower leg are in line. So here we have one bolt, here we have one bolt. So now if we cut it over here and then make it straight like this, so it will look like this figure. So we have turning line over here. So at this turning line, so this will be this leg, upper leg 152 millimeter, and this will be the shorter leg 102 millimeter leg. In the upper leg 152 millimeter leg we have two line of bolt, and in the smaller leg we have one line of bolts. So ultimately the shape will be like this, and the distance or the gauge distance between these two lines is shown over here, which is 64. So 64, but the distance between this bolt and this bolt, it should be measured from the center line between these two bolts, and we have seen that this is equal to GA plus GB minus T in the previous slide. So GA GB minus thickness of this, which is 12.7. So the distance between the center line of this bolt and the center line of this bolt will be GA plus GB minus D. So 108.3 will be the gauge distance between these two lines of bolts. Okay, so now this figure is identical to that of simple plate or straight plate. So now it's easy to calculate the net area. So we need to consider different possible failure planes. So this might be the critical section, then this might be the critical section, or this might be the critical section. Mean failure plane may lie between A and C, AB and C, and AB and D. So if we compare this path, these two paths are same. We have same pitch or same stagger, as well as the gauge length is same. So path ABC and path ABD will be identical. So we can investigate only for one. So first consider path AC, this one. So here grass area we can find, or we can select the area of this angle section from the tables, which is 3060. From LRFD manual we can find this value. Minus, there are two holes, so 2 times diameter of bolt plus 3, so diameter of bolt is 18 millimeter, so 18 millimeter plus 3 times the thickness of this plate, and thickness of this plate is 12.7 millimeter, the thickness of this angle. So it will come out to be 27 millimeters square. So the next path is AB and C. So for path AB and C or ABD, we have grass area that will remain same, and there will come 1, 2 and 3 holes in the critical section. Our critical section will be like this now, from here up to B and then C and then this one. So there will be 3 holes. So N will become 3 plus times 18 plus 3, 18 is the diameter of bolt, plus 3 times the thickness of plate 12.7. So grass area minus area of holes. Now we need to add for this staggers as square over 4G. So for A and B we have stagger value 76, so 76 square, and the gauge value is 64, so 4 times 64. Then for this B and C we have stagger value of 76, so 76 square, and the gauge length is 108.3, so 4 times 108.3. Multiply it with the thickness, so we will get this area. So if we compare these two areas, this area will be the smaller value, and this will control the, this will define the critical path. So critical path will be from A and C. So one thing that I think you should understand, why we provide the stagger, or why we arrange the holes in stagger. So it is actually to increase the area at the critical section. For example, if this hole is at this location, so in that case, so for path AC there will be 3 holes, and when the holes are 3 in this line, so the area will further reduce. To just increase the area of the critical path, we need to stagger these holes. So when we will stagger these holes, so along this line the number of holes will reduce, as well as when the path is this one, so this inclined area, or the inclined area of inclined line will be greater. So we can add this much portion for this larger length. So the length of the critical path will increase when we stagger the holes. Next is the concept of effective area. When some of the cross section